Good afternoon. It's a real privilege to have this opportunity to talk to such an informed audience and a global audience, and particularly alongside such an illustrious panel. My talk provides an introduction to this session, which is on the theme of disasters, and happily this year I'm giving the Institution of Civil Engineers Brunel Lecture, and the theme of that I chose was shifting agendas from response to resilience, which provides a context, I think, for some of the things that some of the other speakers are going to say. Natural disasters are a very significant issue, but they're something we read about in the newspapers and tend to move on and ignore. The reality is that over the last 10 years, they affected more than 2 billion people, and annually the cost of natural disasters is around $100 billion US. To put that into context, that's the infrastructure budget for Africa, the bailout of an American bank, and twice the GDP of a country like Sri Lanka. And although earthquakes still cause the biggest deaths, and that's despite huge advances in countries like Japan and the US in terms of codes of practice, they actually only represent about 4% of the disasters that happen. And the sad reality about earthquakes, which we saw very well illustrated in Haiti, is that there's towns and cities all around the world which are disasters simply waiting to happen because of the poor quality of building construction and the lack of regulations. But although earthquakes cause the highest mortality rates, it's floods that affect the most people. This was starkly illustrated in Pakistan in 2010, when an area the size of Italy was covered by floodwaters and 12% of the population was affected. The reality is that happened again the following year in 2011. And we've just seen Hurricane Sandy in America. Last year it was the floods in Bangkok, the previous year flooding in Brisbane. And cities are being brought to a standstill by floods. And floods, droughts are all part of the sort of suite of weather-related hazards that are affected by climate change. There's a question mark here simply because I gave this presentation in America last week. But the evidence is overwhelming. Floods, storms, droughts are on the increase. The Americans claim that this is actually due to telecommunications and that we can report these events more readily. But I would beg to disagree. There are, of course, other issues that do come into play, such as environmental degradation and rapid urbanization, which I'll come on to in a minute. But in the 1990s, when disasters were recognized as a global challenge, the concern was that they were actually deleting the hard-won development gains. And so UN agencies were very active in setting up the 1990s as the decade of disasters and initiating action around the world to put this subject on the agenda. But today, the concern is money. Disasters are an economic issue, and as you can see from this graph, the cost of disasters is rising rapidly. The key reason for this is simply because disasters are occurring in urban areas, and therefore these increasing costs represent the loss of physical assets. The cost of the Japanese earthquake and tsunami is totaled at around $300 billion US, making it the most costly disaster in history. And if I extended this graph by one more year, I'd be off the scale. But countries like Japan, although it represents a significant economic impact, it's nothing compared to the impact of disasters on countries like Haiti, where the cost of the disaster was only $8 billion US, but that was more than the GDP of the country. And chronic poverty, weak governance, and that economic cost mean that it's going to take decades for Haiti to recover. So these are an issue, disasters are an issue that we need to take very seriously. My focus has been on where are these trends leading us to, and what do we need to worry about in the future? And I think this is the big issue. This photo is actually of New Orleans after Hurricane Katrina, but I could have found pictures of many cities in the world that have been inundated by floods or collapsed as a result of earthquakes. We live in a world that is increasingly urban, and by the middle of this century, about 70% of people are going to be living in urban areas. And we've seen disasters affect cities, from Christchurch in New Zealand due to earthquakes to the flooding in Bangkok, where the implications of that disaster were felt globally. Bangkok is a centre of manufacturing for computer hardware, for car manufacturing. And as a result of the flooding in Bangkok, the cost of hard drives went up by 10% globally. And Toyota's car production slowed in 5 countries, including Venezuela, which is the other side of the world. And this is interesting because urban disasters are putting this subject on the business agenda. But urban disasters are complicated because they're a consequence of 3 key things. The first is simply that cities have historically been located in areas that are highly exposed to disasters because they're on the coasts because of proximity to trade routes, or they're in deltas because of access to fertile land. And this graph shows the top 20 cities in terms of their exposure for weather-related hazards. And these are some of the biggest cities in the world, and this doesn't include sea level rise. But it's not just the accumulation of people and assets in areas that are highly exposed. A bigger issue is also the rapid pace of urbanization, and the fact that urbanization is happening in Southeast Asia, and particularly sub-Saharan Africa. And in these places, financial resources, effective governance, and political will are lacking, and therefore the consequence is unplanned urban development that's characterized by infrastructure deficits, poor quality buildings, and deteriorating ecosystems. Whether it's runoff from new developments, destruction of coastal ecosystems to build roads, lack of investment in stormwater drainage, inadequate watershed management, all of these things are massively creating risk in the urban environment. And of course, the people that are most effective are the poor, who tend to be located, such as here, on marginal land. And already 1 billion people live in informal settlements, and unfortunately that is a number that's rising. So I think a challenge for us as engineers is actually to think very specifically about how can we reduce the risks for the poorest 1/10 of the population. Urban areas, though, mean, I think, a completely different approach to thinking about disaster management. They're characterized by complexity. Large numbers of people who are living in close proximity, and they're dependent on the urban system, the institutions, the infrastructure, the knowledge networks that allow the city to function. And so it's not just a case of an overlay of hazards on vulnerable populations, which is traditionally how a lot of disaster management has been approached. Actually, what we need to look at is the impact of those hazards on the urban system. If a power station goes down as a result of sea level rise because that power station's on the coast, and you've got centralized energy infrastructure, the whole energy supply in the city is likely to fail. If that energy is responsible for the telecommunications networks and the radio links, people won't understand what's happening because the radio stations will go down. And if the water is being pumped from kilometers away, which is the reality in many cities, the water supply may also go down. The reality of this is it makes it very difficult for us to predict and therefore prevent urban disasters. Overlaid on this is another challenge, climate change. And this, I think, brings considerable uncertainty. There's estimates of how many more people are going to be affected by climate change in the next 4 to 5 years. But actually, there is no scientific consensus, and we increasingly realize that a lot of the scenarios are non-conservative. Therefore, we don't really know what's going to happen. And as this diagram shows, the issue of climate is very intimately linked to the issue of disasters. And climate change adaptation, which is about tackling the local implications of climate change, is critical. It's much more complicated than mitigation because it's context-specific, And it also is a function of not only increasing hazards, like the intensity of storms increasing, but also new hazards, like glacial lake outflow flooding, GLOF it's known as, which is when ice dams melt in the Himalayas, releasing huge amounts of water, or changes in vector-borne diseases in tropical countries. So there's more dengue, more malaria. But it's also because underlying vulnerability is affected by climate change in terms of things like water scarcity. All of this means that we have to approach things in a different way. Our ability to understand and model the dependencies and interdependencies in an urban system is limited, and there are valiant attempts by engineers to build computer models that model these complexities. But I have yet to see a computer model that actually effectively models human behavior, particularly human behavior in an emergency. But also uncertainty, which challenges traditional risk management practices that have tended to be hazard-specific and are based on a predict and prevent paradigm. If we don't really know what's going to happen over the next 50 years, it makes it very challenging to design the infrastructure on which we depend. And this is where resilience comes in. Resilience is a paradigm shift away from the traditional areas of response, preparedness, and prevention. And there's lots of definitions of resilience, but actually I find this word cloud that we did based on 30 documents much more helpful, because it highlights the two really important things about resilience, which is that it's about the ability of systems to perform and to deal with disruption. And really, that's what resilience is about. It's about, the ability of systems to perform so the disruption doesn't result in collapse and breakdown. And this is very different to the way the way that we have approached things in the past. The goal is to create safer and more resilient communities at every level of society, who understand the risks they face and are able to prepare, withstand, and recover from catastrophic events and the accumulating stresses that are likely due to things like climate change. Inherent in the notion of resilience is acceptance that disruption may occur and that it may result in significant change, but what matters is that you can continue and that the well-being of people is maintained. I was speaking in New York a couple of weeks ago, and there is sort of denial that Hurricane Sandy might ever happen again. But the reality, of course, is that it will. It'll have a different name. We might be on C or D with the alphabet a few times round. But what matters is not that New York may get hit by another hurricane, but actually what can be done now in New York to ensure that the consequences of the next hurricane are less severe and those consequences are contained. This is a diagram from some work that we've been doing with New York City, highlighting 5 building blocks of resilience in terms of redundancy and flexibility, which are challenging because they actually go against some of the sustainability agendas of efficiency. And these two concepts need to be brokered. But also the importance of safe failure, rapid rebound, and constant learning. So I just want to quickly throw in 6 suggestions of how we might, as engineers, tackle this. The first is to shift towards a systems perspective, to not look at what we do as on a project-by-project basis or in isolation as engineers, but to recognise that what we do links to ecosystems, to people, to institutions. And these are themes that other speakers have talked about over the last day or so. We also need to accept failure. Engineers are not omnipotent, although actually that is the perception of a lot of the public. When failure occurs, it's not very often, but it can be catastrophic. We saw that with the levees in New Orleans after Hurricane Katrina. We saw it with the failure of the Fukushima plant in Japan. And therefore, when we're design to thresholds after which failure will be catastrophic is not really a viable way forwards, something that the seismic community have already addressed. Codes and practices, regulations, rules are vitally important, and the change in countries like Japan, the change in the impact of earthquakes as a result of the introduction of those codes is really stark. And countries like Chile introduced codes for seismic risk in the 1960s. And although the earthquake in Chile was as big, in fact bigger than the earthquake in Haiti, the loss of life was trivial. And that was directly a consequence of codes and planning regulations and good engineering practices. But the reality is that many of the most vulnerable countries in the world, codes don't exist. If they do, like in Indonesia, they don't apply to simple single-story buildings like schools and health centres. And they're only effective if they're part of a culture of safety that includes engineering education and enforcement. So I advocate that as much emphasis needs to go on just promoting safer construction practices, building on how people create the infrastructure around them already, looking at what people do and using our engineering knowledge to improve it, rather than propose an alternative pathway to comply with a code which may be very tricky. This is on the theme, really, of appropriateness. I am awed by the ingenuity of the engineering profession. And when you look at disasters, we build some of the tallest buildings in the world in countries like the Philippines, which are highly vulnerable to earthquakes. We build heroic structures like the Thames Barrier to protect London. And that is one of a whole series of flood defences with a value of nearly $10 billion US. But the reality for most of these cities that are highly vulnerable to sea level rise is that that is a bill that they will never afford. And there also isn't the technical capacity locally to design, operate and maintain this kind of infrastructure. So in cities like Ho Chi Minh, we need to be thinking in a different way, thinking about the cumulative effect of smaller interventions, which can be adapted as we learn more in the future. And I'm talking about things like water retention, like sustainable urban drainage systems. And these are newer practices in urban design, which are increasingly coming in to the world in Europe and the US. But when I travel in Africa and Asia, they are frequently absent. And the default is to borrow more money from the World Bank and build another dike. I'll just skip that one because we're short of time. I think the final thing I just wanted to say was the importance of business and the business case for this. It's very easy to sit in our ivory towers and intellectualize subjects like disaster risk. But if we can make them a business reality, I believe that they will really happen. This is a picture of a car manufacturing facility in Turkey, and the black line is the fault line where the 1919 earthquake happened. Being a Japanese manufacturer, their brief in designing this facility was please ensure that it's operationally critical so that we can open our business a day or so after the earthquake. And when the earthquake happened, which happened rather sooner than they expected, the buildings and all the equipment therein performed, as designed. But what everyone had overlooked, including the engineers, was that that facility relied on people to operate it. And those people lived in poor quality housing nearby, which had collapsed. And the facility remained closed for a month. So this story I tell because I think it illustrates a business case for disaster risk reduction. And I think we as engineers have a very big role to play in helping articulate that business case so we can engage a wider group of people in this debate. This is my final slide, which is about rising to the challenge. That challenge has already been articulated. In 2005, 168 governments signed the Hyogo Framework for Action. And in 2011, they conducted a midterm evaluation to see what progress was being made globally towards reducing disaster risk. I read that report with interest. It highlighted 3 areas that required urgent attention where nothing had been done: the integration of risk reduction into infrastructure projects, safer schools and hospitals, and addressing urban risk. Miraculously, when I scanned through the document on a word search, the word engineer, engineering, was notably absent. And when I looked in the bibliography of contributors, there were no engineers, a few urban planners. So I think if we are going to rise to this global challenge, and I do think that we as a profession have a lot of the know-how that's needed, we need to engage more proactively in the debate, because by our actions, we'll either compound disasters or diminish them. Thank you.